So now let's start. Let's try and understand what is the big O notation. Right. Point number 1. Right. Consider an algorithm. Consider an algorithm whose efficiency is write this. F of n is equal to 8.023 n square plus 7n. Pay attention to writing. Same point. At very large values of n, write this. F of n directly proportional to n square. Underline very large. Now tell me one thing, do you already know this, what you wrote?
Yes.
Okay. Now, point number 2 is almost same as point number 1, just pay attention while writing, okay? Point number 2, if we designate n square as g of n, you can look over here. If we designate n square as g of n, then we may say that as the value of n keeps on increasing, like this, f of n directly proportional to g of n. See, if you paid attention while writing that point, you must have realized what we are doing is we are designating n square as what?
G of n.
And then we are writing that as n increases, f of n will become directly proportional to
G of n.
So basically point number 1 and 2 are same. Okay. 3. Point number 3. We identify writing. The same fact can also be stated as now look on here. Now whatever you wrote in point number 1 and 2, that same fact can be stated this way. How? You can write f of n is, read it,
On the order of G of n.
or you may write this way. Wait. You may write this way. F of n is this thing. Now while writing, what we do is we make a big O and then in bracket we write G of n. But when we read it this way. We read it f of n is what? Big O of G of n. So whatever you wrote in point number 1 and 2 is can be basically written this way. That f of n is big O of G of n. Wait. Now, if somebody says that f of n is big O of G of n, mathematically what it means? So mathematically it means that f of n is less than or equal to c into G of n at, read it,
Very large values of n.
where c is a positive real constant. Do you understand that? So this statement mathematically means this line. Any doubts here? I'll take an example also to make you understand this. Okay. Now you wrote can be stated as, right? Now copy this box. Okay. Next point. Mathematically it means, next point. Mathematically it means that there exists a positive real constant C such that copy this, such that f of n less than equal to c into g of n at very large values of n. Okay, any doubts? Okay, now let's try to understand this with the help of an example. Now what you see over here will be mathematics. You should know mathematics to understand this. Now let's consider an algorithm whose efficiency is this. Read. Be attentive. Huh? Now let's say I write n square plus 100n, and on the right hand side I write 2n square. Don't wonder why I wrote it, just understand things mathematically. Now I will call this LHS, left hand side. I'll call this RHS, right hand side. Okay. Now tell me one simple thing. If n is equal to 100, if n is equal to 100, what is the relationship between LHS and RHS? Relationship means, are they equal, lesser, greater? What is it? You need so much time concept. When n is 100, the LHS and RHS, what is the relationship? Equal. Equal. They are equal. Alright, don't expect me to explain all that. Huh? Okay, go home, take a calculator and check yourself. If n is equal to 99, be attentive. Who is lesser, LHS or RHS?
RHS.
Very good. If n is equal to 101, who is lesser?
LHS.
Huh?
LHS.
If n is equal to 102, who is lesser?
LHS.
Very good, very good. This is the only batch in which people have answered so fast. Anyway, so now all this what I spoke in last 1 minute, see how I'll write it. Look over here, I'll write it this way. The LHS is less than or equal to the RHS for those values of n which are greater than or equal to 100. Do you understand this? Okay. Take it. Now be very attentive. It's very simple if you are listening to me carefully. See, if you see over here, what did we understand? What did we study over here? Be attentive. It's very simple. We understood this way. If f of n is big O of g of n, then mathematically it means that f of n is less than or equal to c into g of n. Right? So what we studied over here is that if this is true, then this is true. That's what you said. That's what we said. Now over here f of n is this. Okay, this thing, n square plus 100n. Now compare 2n square, see, compare this entire expression. Compare this entire expression with this line. Tell me who is f of n? Who is c? 2. Who is g of n? So now all you need to do is just play with words. If this is true, this line is true, then you say this line is true. So if this line is true, if f of n is less than equal to 2n square, because f of n is less than equal to 2n square, therefore you may say that f of n, any idea what I am going to write? Is big O of n square. Very good. Is big O of g of n. You are right, by the way. where g of n is equal to
N square.
and c is equal to 2. Did you understand what we did? Okay, because this relationship holds true, you may write f of n is big O of n square. Any doubts here? Sure. Now we are going to study something else which is much more difficult. You have to be very attentive, okay? Now this is done. Again we will be talking mathematics, be attentive. Now let's say n is equal to 100. When n is equal to 100, what is the value of 2n square minus n square plus 100n? That means RHS minus LHS is how much for n equal to 100?
0.
How much?
0.
So I write 0. Okay. Now let's say n is equal to 101. So now this minus this, let's say it is equal to K1. Tell me K1 is positive or negative?
Positive.
Okay. Let's say n is equal to 102. This minus this equal to K2. K2 is positive or negative?
Positive.
One more. N is equal to 103. This minus this is equal to K3. It is positive or negative?
Positive.
Okay. Now comes an important question. K1, K2, K3 are positive. Now tell me what is the relationship between K1, K2, K3? Is K1 less than K2 less than K3 or is vice versa? Is K1 less than K2 less than K3 or greater than K2 greater than K3?
Less than.
Sure.
Yes.
So that is a very important property actually. Be very attentive. You know what this mathematical property means? It means this way. Be attentive. As the value of n keeps on increasing, f of n becomes smaller and smaller than some multiple of g of n. Listen to me carefully. As the value of n keeps on
Increasing.
f of n means this becomes smaller and smaller than some multiple of.
G of n.
When I say some multiple, who is that some multiple over here?
2
2 of g of n. Who is g of n?
N square.
So you know what property did we study over here? That as n keeps